Hi, and welcome to the second part of my series on understanding integers. Today we'll be looking at doing the four basic mathematical operations using a picture model and an abstract model. In the last video, we looked at addition and subtraction of integers using integer counters. Let's do a brief recap. When I add 5 plus 4, this 5 represents positive 5. So we represented this with 5 positive integer counters. And we represented plus 4 with 4 positive integer counters. So 5 plus 4 was the sum total of all the integer counters. And we have 9, but all of them are positive. So our answer was positive 9. Remember, the positive is understood, so we need not put in the positive. But suppose if we had large numbers to deal with, then that would mean we would need a lot of integer counters. This tells us that this particular method is not the most efficient method of evaluating integers. So away with the counters. Let's introduce the addition and subtraction table. The same task can be accomplished using the addition and subtraction tables. Positive 5 will be placed under the positive column, and positive 4 will be placed under the positive column. Since we cannot nullify anything, then the sum total would be 5 plus 4 equals 9 tiles. But how can we be reminded of the sign that 9 would carry? Just look at the sign to the top of the column, this. So our answer would be positive 9. Let's look at another example. If I had 25 minus 14, I would use my addition and subtraction table as well. Positive 25 means I am going to put 25 in the positive column, like this. Minus 14 means I'm going to put 14 in the negative column, like this. Oh, but we reach to a point where there are some discrepancies. Recall when we used integer counters, we had paired off the positives with the negatives. It is difficult to do the pairing as is. So what we may have to do is to create a number bond for 25, in which one of the number would be 14. Let's see, 14 and how much would give me 25? I think it's 11. So if I remove the 25 and I put 14 and 11, then I will still get 25. But after putting it like this, I can nullify the negative 14 with the positive 14. So these two cancel out each other, leaving me with 11. So how do I know the sign of these tiles? Well, I look at the column to the top, and that would be positive. So answer would be positive 11. This too may not be the most efficient way, but it might be a way of transitioning from what you know about the integer counters to this. We could have used a more efficient way of obtaining this answer. Here's what we could have done. Here's our addition and subtraction table. We place the positive 25 under the positive and the 14 under the negative. Then we look for the least number of tiles and transfer it to the adjoining column, like this. Then we do a subtraction operation. When we subtract the 2, we would have 11. But how are we to know that the 11 is positive or negative? You simply look at the column to which the operation was done. The top of the column gives you the sign, so the answer would be positive 11. Let's look at another example. if I had negative 84 plus 43, I am going to put the negative 84 goes under the negative. We will just put the 84, and the positive 43 goes under the positive column 43. Again, you look for the column with the least number of tiles. The least number of tiles are under the positive column. So we move these tiles to the neighboring column like this. Then we perform a subtraction. This would give me 41. So we have 41 tiles in excess that were not nullified. But what sign would this 41 take? This 41 would take the sign that is to the top of the column. That is the negative. So our answer will be negative 41. Let's look at another example. Suppose if I had negative 45 minus 59. Using our table, we see that both the 45 and the 59 are negative. So both of them can go on one column, that is the negative column. Since there are no positives to nullify any tiles, we simply add both tiles to give me 104 tiles. So what would be the sign of the answer? Our sign would be determined by the sign above the column. So our answer would be negative 104. The takeaway is, when adding integers with the same signs, that is plus or minus, you sum the number of integer counters and keep the sign of the counters added. The second takeaway is, whenever you are adding integers with opposite signs, you find the difference between the number of integer counters and keep the sign of the greatest number of integer counters. In the last video, we looked at multiplication and the division of integers using integer counters. These were the results. From these results, we had a few observations. The first observation, we recognized that the product or quotient of numbers followed the normal rule for multiplication and division. Take for example, 2 times 3. 2 times 3 is equal to 6 because we had 3 sets of 2's. And 3 times negative 2 equals negative 6 because we had 3 sets of negative 2's. The same applied for division. The second thing we observed was a plus is the same as a plus. This can be observed in our first equation, where we see the sign in front of the 3 is positive and the sign in front of the 2 is positive. Remember, we interpret that plus as being the same as. So what is the same as a plus? A plus is the same as a plus. Hence, we have a plus in front of our answer of 6. We also observe the opposite of plus is minus. Take the second equation for example. We see before the 3 is a negative and before the 2 is a positive. Remember, we are going to treat the negative or minus as the opposite of. And what is the opposite of a positive? The opposite of a positive is a negative. Hence, our answer will be negative 6. Our fourth observation is that a minus is the same as a minus. This can be seen in our third equation because the sign in front of the 3 is positive and the sign in front of the 2 is negative. Remember, we are treating the plus as the same as. So what is the same as a negative? The same as a negative is a negative. Finally, we can see the opposite of minus is a plus. Looking at the fourth equation, the sign in front of the 3 is negative and the sign in front of the 2 is negative. So what is the opposite of negative? The opposite of negative is positive, and hence the answer would be positive 6. These are similar to that of the multiplication rules. Let's take a look. If we had a plus times a plus, remember we said we are going to treat the plus as the same as. These observations follow the same thing as the multiplying integer rules. If we can observe that a plus times a plus is the same as saying what is the same as a plus? And what is the same as a plus? A plus is the same as a plus. The second rule of multiplication, where we have the opposite of minus is minus. Take a look at this rule. Remember, negative is interpreted as the opposite of. So the opposite of plus is minus. The third rule, minus is the same as minus. This is true because when we have plus, plus is interpreted as the same as. So what is the same as minus? Minus is the same as minus. The opposite of minus is plus. Here, when we see minus times a minus, remember minus means the opposite of. So we can say the opposite of a minus is a plus. So the truth be told, you don't need to remember all of these rules if you would have made the observations on the right. However, you may find it handy to recall them. So what's the takeaway? Whenever you multiply or divide two of the same signs, your answer is always positive. Take a moment to look at the first two rules in the multiplication of integers. The second takeaway is when multiplying or dividing two opposite signs, the answer is always negative. Take a look at the multiplying integer rules, the last two. These apply not only for multiplication, but also for division. Let us look at the multiplying integer rules in a different context, because some students may prefer another mechanism to recall these rules. Another way of recalling these rules is the use of our multiplication or division triangle. This is our multiplication or division triangle. Here we have a triangle with two negative signs and one positive sign. The thing with this triangle, you must remember the first of the four multiplying integer rule. Whenever you are multiplying a plus by a plus or dividing a plus by a plus, the answer is always plus. The other rules we can determine using our triangle. If we wanted minus times a minus, what we do, we place the hand over the sign that exposes minus and a minus, like this, so that we will know we are multiplying minus times minus. The sign below the hand is the result of multiplying minus by minus. That is a plus. Let's look at this one. Here is our triangle again. if we wanted to multiply plus times a minus, then we place a hand over a sign that would cause the exposure of only a plus and a minus, like this. And the result of multiplying a plus by a minus would be the sign that is below our hand, which is a minus. Similarly, if I wanted minus times a plus, I take the same triangle and place a hand over the sign which caused me to expose just a minus and the plus, like this, so that the result of multiplying a minus and a plus would be that sign below the hand, which is a minus. I trust you enjoy this video. Using this video along with the previous integer video would help alleviate all your fears about integers, and hopefully would help you to be better, stronger math students. See you in the next video. This is the end of this video. Please don't forget to like and subscribe.